So our change of base formula helps us evaluate logarithms that we can't do without a calculator. And it helps us punch in the values into our calculator. So let's say we have this log base 3 of 13. So what I'd be saying is 3 needs what exponent to get out 13? Well, I have no idea. Without a calculator, I don't know what would go there. I do know that 3 squared is 9 and 3 cubed is 27. So I expect the value I get out will be between 2 and 3, but to get more specific than that, I can't do it. Other values we've looked at so far, if we've used our calculator, have been logarithm base 10 or natural log. So if we go to our calculator, what you can see is, and like I've said before, we can either type it in, or if you go to function on this calculator, you can see we have our natural log, and we can type in input. We can also type in log and have our input. What you'll notice is that I can't type in log base 3. I can't edit that. Now there are some calculators out there that will let you do that, but most calculators, how they operate, don't let you type that in. So we want to be sure we cover this formula so that we can calculate with calculators that are restricted to natural log and base 10 logarithm. So what I need to do is, how can I calculate log base 3 of 13 with a calculator if I can't type in log base 3? And that's where we have the change of base formula, is we're going to change the base 3 into a different base. And the key is that we're going to want to change it into base of e or base of 10 so that we can type it into the calculator. So the change of base formula goes that if we have this logarithm with some base a, and inside the logarithm is this number m, what we can do is change this to a different base, as long as the base is the same in the numerator, same in the denominator. In the numerator, inside the logarithm, we just have the value from our original logarithm. In the denominator, we have the base of our original logarithm. Now, that's just a mouthful reading out loud. Let's see it applied, and it makes more sense applied. I mean, it makes a little more sense applied. The key is, they're telling us we can use any base over here. We want to use base 10 or base e, for that reason of wanting to be able to plug it into the calculator. So that example that I wrote up above there, so logarithm base 3 of 13, what I can do is change this to base 10. So I go logarithm base 10 over a logarithm base 10. So I end up with a division of two logarithms that are the same base, and they use base 10. And then we just need to make sure that the correct pieces go to numerator, denominator. It's going to go value to the numerator, base to the denominator. And if you're worried about mixing those up, I think like the base is in the basement of the logarithm, and it's in the basement of the division, so it's down low. So what we'll have is the value of 13 up in the numerator, and the base of 3 in the denominator. And now I have something that I can type into the calculator. So let's see what it calculates to. And I had my guess of that it's between 2 and 3. And now I can type in, let's see, logarithm of 13 divided by logarithm of 3. And there's my number that's between 2 and 3. So I get 2.33. So that's the exponent that I would need on 3 in order to get 13 out. So I can change this to a base 10 calculation. So that's my change of base in this change of base formula, is that I started with something in base 3 and then I ended up with the calculation in base 10. What if I had changed it to base e? In fact, I most often go to this base e form, the natural log. There are just some calculators where that button's a little easier to find. So with using the Desmos calculator, that really isn't the case here. But most typically, I use this form. So what that would look like is with log base 3 of 13, and I'm changing it to log base e, so my natural log over natural log, and we have the value in the numerator, base in the denominator. So it's the same setup as up above there, I'm just using base e instead of base 10. So let's see what happens when I do that. Natural log of 13 over natural log of 3, it's the same exact answer, because they're both answering this overall question of what exponent do we need on 3 to get 13 out. So the exponent shouldn't change at all based on how we change the base in the formula. So that's where we can see really we can use any base as long as it's consistent. And with that, if you always want to use base 10, then always use base 10. If you want to always use the natural log, always use the natural log. Whichever one you prefer, whichever is easiest for you to interpret and type in the really comes down to which is easier to type into the calculator. So either way. So let's get some practice with these. So we have these logarithmic expressions, and these are expressions that we can't type into the calculator as they are, so we need to use this change of base formula. And I'm going to use the natural logarithm form just because it's what I'm most used to, but there isn't any reason beyond that. So if you want to go through these with the base 10, you can compare and see how you get the same exact answer out. So this log base 2 of 5, and again, you could start by thinking up of what you expect to come out. Like this is saying 2 to what power gives us 5? Well, I know 2 squared is 4, and that's pretty close, so I'm going to expect a number that's a little more than 2. So with this, I'm getting an answer out, but I need to change the base. So I'm going to change this to the division of 2 natural logs, where I have the value in the numerator, base in the basement. So then I can go to the calculator and go natural log of 5 divided by natural log of 2, and I can see my value that's a little more than 2, that 2.32. So that's going to be a 2.32. So the idea being that 2 to, and this will be a little off, but to a power of 2.32 is the same as 5. So that's what we're getting out of this, the exponent that would fill in the blank there when that exponent isn't a nice whole number. All right, b here, this is a little tricky to think about without a calculator, so I'm thinking 5 to what power would give us 1/2. However, something I could notice is that the exponent, since we're starting with this nice whole number of 5 and we end up with a fraction, I'm going to expect an exponent that's negative, something that would throw that 5 into the denominator, and then it needs to do some stuff to get a 5 into it too, but I'm not going to worry too much about that. But in terms of what I expect, I'm expecting a negative number to come out. And you don't have to do this part. I'm just trying to give you some instinct in terms of values that come out of logarithms. That's all I'm talking about here. So, change of base formula. So I'm going to have natural log over natural log. And just again, you could use base 10 log, and that would be totally fine too. In the numerator, I'm going to have that value of 1/2. In the denominator, base. So, natural log, I'm just going to edit in here, 1/2 over 5. And that's a negative number like I expected, and a 0.43. So that tells me that if I take 5 raised to an exponent of negative 0.43, I should get 1/2 out. All right, let's go up here to C. So, again, just some instinct with what should be coming out here. So, 4 to what power would give us 15? Well, 4 squared is 16. So I'm thinking this is going to be a little bit less than 2 is what should be coming out here. The squared would take us over that number, so we want to go a little bit back. So, natural log of 15 over natural log of 4 is what I'll type into the calculator. So natural log of 15 over 4, and there's my value. That's a little less than 2, so 1.95. Alright, our last example here, I'm taking 20 raised to a power to get 10 out. Sounds a little tricky. It's probably going to be a fraction, like it would be the idea of taking the root of some level of that number. So I'm going to expect a fraction out. It should still be positive because I didn't get a fraction out over here, but something between 0 and 1. Okay, change of base. I'm going to go natural log of 10 over natural log of 20 and type that into the calculator. 10 and 20. So I have a fraction between 0 and 1 there with a 0.77 if we round to 2 decimal places. Now if you had done this with base 10, there would be some simplifying you could do before the calculator. It's not required by any means, but we would have log of 20 over, nope, I switched it, sorry, log of 10 over log of 20. So again, same exact thing between those two expressions. It's just this is base E and this is base 10. But what we would get out is you could simplify a little bit, that this would be the same thing as 1 over log of 20. Because again, base 10 and base 10 there would mean 10 would need an exponent of 1 to get 10 out, so that would just simplify. And that would be the same exact thing. So if you're using base 10, you would maybe see that you could simplify first, but also you just type it in the calculator like that, because in the end, what we really want is this value. Just want to see some sort of setup for your change of base formula, and then from there, it's just plugging into the calculator.